make this money rain on me. Come make this money rain on. Come make this money rain on me. Come make this money rain on. 1, 2, 3, go. Risk, 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 risk it on. Risk, risk, risk it on. Risk, correct, shoot.
Hello, good day viewers. I want to introduce the topic permutation, but I realize permutations and combinations are somehow related. This is why I want to make the introduction at the same time, but subsequently I will be dealing with permutations before going to combinations. So what are permutations and combinations? What is the difference between the two? I will not be giving you definitions, but for a comprehensive explanation, you will be able to distinguish between the two. Okay, suppose we have two letters, A and B. The question is, how many ways can we arrange these letters? We can arrange them in two different ways. AB, or let me say BA. Can you see that we have two different arrangements, but a single combination, because AB and BA are all letters AB. So in combination, they are regarded as one, but in permutation, they are considered as two. So we have two permutation here. But one combination. Can you see the difference between the two? Permutation is concerned with the arrangement, where order does matter. AB and BA are two different arrangements in permutation. But since AB and BA are all letters AB, they are going to be considered as one combination. In combination, order doesn't matter. No matter how you arrange it, despite they are the same letters, they are going to be considered as one. Suppose we have another one, A, B, C. How many ways can we arrange A, B, C? We can arrange it as A, B, C. We can also arrange it as A, C, B. We can equally arrange it as B, A, C, B, C, A. We can arrange it as C, A, B, and finally C, B, A. How many ways? 1, 2, 3, 4, 5, 6. We have 6 different permutations. But all of these are considered as one in combination, because they are all letters ABC, just that they are arranged in different ways. So the arrangement of these letters in different forms is what permutation is telling us. But irrespective of the order in which they are arranged is what the combination is talking about. So we have one combination, 6 permutations. So this is where the term factorial comes to play. Observe something here. Let me start with this one. We have 3 items, but we have arranged them in 6 different places or in 6 different ways. To choose which number comes first, you have 3 options. The first letter could either be A, B, or C. 3 options. But having chosen the first option, you have 2 letters left. And you have to choose among the 2 letters to decide which one comes second. After choosing the second one, you have only 1 letter left, which is 1. Can you see that? 3 times 2 times 1 is equal to 6. And this is just a definition of factorial. This is equal to 3 factorial. Remember, factorial means that number or a letter multiplied by the next number before it, multiplied by the next number before that one, up to 1. If you have 5 factorial, it means 5 times 4 times 3 times 2 times 1. If it is 6, 6 down to 1. Coming here, we have 2 letters. To choose which letter comes first, you have to choose among the two. So we have 2. Having chosen the first letter, you have 1 left, so that is which is going to be considered next. 2 times 1 equal to 2. This is why we have 2 permutations here. And 2 times 1 is the same thing as 2 factorial. All right. Coming back to combination. No matter how many times you arrange ABC, you will always have a single combination. The only time you will have a different combination is when you decide to choose some R combination out of the total. Maybe you want to choose R out of N, where N is the total number. Like here we have ABC, N is equal to 3, while R could either be 1, 2, or 3. So if R is equal to N, you will always have a single combination, because here we have 3 items and we are choosing the whole 3. R is equal to N, we have a single combination. But what if you decide to choose 2 out of 3? Let us do that and see. So first we have A, B, and C, and we want to choose 2 at a time. We can have AB, right? Choosing 2 out of 3. We can have AC. We can have BA. We can have BC. We can have CA. And lastly, CB. 1, 2, 3, 4, 5, 6. We have 6 different permutations in choosing 2 out of 3. Or in arranging 2 out of 3. But we have only 3 combinations here, because remember, order doesn't matter in combination. So AB and BA are all the same thing in combination. There are 2 numbers interchanged in different places. So we have 6 permutations, but what? 3 combinations. This brings us to an important formula that would always guide us in deciding the number of permutations and combination in a group of items. Okay, let us apply this as an example where N here is equal to 3 and R N equal to 3 and R equal to 2, because we are choosing 2 out of 3. So for permutation, we have N permutation R, which is equal to N factorial. Remember, we know what N factorial is all about. Divide by N minus R factorial. This is what defines permutation. But for combination, we have N choose R is equal to N factorial divided by N minus R factorial, then also multiply by R factorial. We are going to substitute from this formula to see whether we are going to get 6 and 3 respectively. For permutation, this is equal to, remember, N is 3, so we have 3 factorial divided by N minus R. R is 2, 3 minus 2. Okay, let me even write it, 3 minus 2 also factorial. This is equal to 3 factorial means 3 times 2 times 1. So we have 3 times 2 times 1 here, divided by 3 minus 2 is 1. So we have 1 factorial. Remember, 1 factorial and 0 factorial are all equal to 1. So we have 2 times 3, which is 6 times 1 is 6, divided by 1 is still equal to 6. This is equal to 6. Can you see that? We have 6 permutation. Coming down here, we have 3 factorial divided by 3 minus 2 factorial multiply by 2 factorial. 3 factorial is 3 times 2 times 1 divided by, this is 1 factorial, which is the same thing as 1. Then we have 2 factorial, which is 2 times 1. Can you see this will cancel this? What we have left is 3 divided by 1, which is equal to 3. Can you see that? In combination, we have 3 combinations here. in choosing 2 out of 3, but 6 different permutations in arranging 2 out of 3 items in ABC. So this is just an introduction to permutations and combinations. Subsequently, we'll be dealing with problems that are related to permutations before going on to combinations. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.